The Mars mission?
Human mission to Mars. People going to Mars.
Mars क्या है?
Just say putting humans on Mars?
Putting people on Mars?
The Elon Musk one? I kind of a little bit know about it. He wants to live on Mars or have people live on Mars.
Oh, that's not even possible, right?
I don't even know. I think Elon Musk is a little crazy.
Wasn't there no oxygen on Mars? Question.
Easiest way to isolate myself.
I thought, wait, how the temperature on Mars is not, we can't go to Mars. It's not, we're not capable of.
I think if we ever actually get the way of getting people there, just colonizing it's going to be a pain.
I don't think anybody should colonize on there.
I think the biggest issue with it is the amount of time it takes to get to Mars with our current technology. It takes a year to get there and back.
I'll do it if I make money. A lot. Because great to discover new stuff.
I think it's shit.
There's no real buildings like in New York, and there's no crime in Mars at the moment, so I would be a little bit useless up there.
I mean, space is cool. I like rocks. No further comments.
3, 2, 1. Liftoff of the Falcon 9.
Vehicles pitching downrange.
Stage 1 prop is nominal. Stage 1 entry startup. Stage 1 is transonic. Stage 1 landing marine startup. Stage 1 landing leg deploying.
Falcon 9 has landed.
Hello and welcome back to another episode of AT Talks. I am your host, Akin Masoodi.
I am Tajammul Ashraf, and the last episode of AT Talks went surprisingly well.
Indeed it did, and we got a lot of likes, comments and views for it. Some critiques also, and some of which we have tried to improve upon in terms of the audio and video quality. So this one hopefully should be even more entertaining and even more fun to watch. So let us begin this episode of AT Talks. So Tajammul, I'll give you a scenario.
Okay.
If each time you're traveling outside the state, the airplane company that you were traveling with, imagine if they had to dispose the plane off and rebuild it from scratch.
That's what exactly happened with the rocket industry. And I'm pointing to a certain, aspect. That is Falcon 9.
Falcon 9, indeed. That's exactly what I was talking about. So Falcon 9, if you don't know, guys, was the first rocket booster, an actual rocket that could send things to space. You might have seen in NASA's videos and everything. It was the first rocket booster that was capable of flying, sending the payload to the outer space, coming back, landing back vertically, and then it could be refueled and then reused, and it could go again, take up a flight like commercial planes these days do. You have a plane, you sit in it, book a ticket, it flies, you have to refuel it, and you can reuse it. But the question is, why build something like this?
Exactly. What is the drive? What is the motivation behind it? Right. So in this episode, we'll understand what is the, we'll cover all the aspects of reusable rockets, the technology behind it, the person and the company behind it. What are the heights we are going to achieve? Correct. And what is the mission, that is we are going to achieve using this, technology.
Exactly. In fact, you touched the real point. What is the motivation behind all of this? In fact, this was the first time. I mean, we have not really had vertical landing rockets. In fact, we have never had rockets that could really be reused prior to Falcon 9. Correct. So Tajammul really touched on a point. What is the motivation? And the core motivation that I would say is to make humans a multi-planetary species.
Exactly. That was the core, motivation behind this, so that it can be, it can be accessible to a common person. Right.
Correct.
Before this technology, rockets were made using billions of dollars, and then they were sent, and there was no comeback.
Correct.
Right.
Agree.
The technology was wasted. The resources were wasted. Right. Now, whatever we're sending to the outer space, we are getting it with full amount. So this means whatever we're sending it, we'll be getting it back, same as we have sent it.
Correct. 100%. 100%.
Right.
And
now, I would like to add, sorry to cut it here. So now the only limit is the distance. Right. You talked about the multiplanetary, concept. So the nearest planet is, and the habitable, to some
Almost,
extent
yes, correct.
habitable is the Mars.
Agree.
So the company that's working on it, I would like to share with the viewers. SpaceX is the company that's working, tremendously, and that has achieved a lot of feats in this domain. Would you like to add something here?
Yes, SpaceX, the company founded by Elon Musk. I think we had something on his full name also, Elon Dream Musk. But anyway, so this is the guy who has not only founded SpaceX, but also founded multiple other companies, Tesla being one of them. Tesla, the car company, electric car company.
He's actually the chief engineer of SpaceX. He is, angel investor, he's CEO, and he is a product architect of Tesla Inc. Recently, he, incorporated Twitter into his pocket,
Yeah,
right?
exactly. The guy who bought Twitter is the same guy. If you don't know, people who don't know, Elon Musk is this guy who recently bought Twitter, who also
it's
found...
a very interesting story, starting from XCOM or PayPal and landing to SpaceX.
That is a huge milestone. Exactly. He has founded multiple companies, other companies also. I think he started by building like a game or something. I'm not sure exactly.
And some companies are, they don't come to the limelight, like Neuralink, SolarCity, right? These are the companies, the boring company, as we'll share in the
kind
podcast.
of like side projects, right?
Exactly. So these are companies that are doing the fundamental jobs in the main SpaceX, right? These are the aids. So I think we should share with the viewers what the journey of this person is and how he developed this concept of reusable rockets. Because
exactly.
It was I as far as I remember, it was announced in 2013 or 2014,
somewhere around
in that
yes.
era.
Yes.
So we'll discuss how he reached there. What was the prime motivation
and what was the end goal.
And what was his goal? What is his vision, right? So the viewers can understand what we are going to discuss in the second half of the podcast. That is the Mars mission.
Correct.
The inhabitants of humans, the future of humanity.
Correct. The future of humanity. I like how you put it. Right. Exactly.
Right.
Because the thing is, see, I want to add a few things here, and then I would like to speak a little bit here because, see, the goal, and I would like to summarize it for the viewers, is that the end goal is really to make the species multiplanetary, meaning you want to have this consciousness on multiple different planets, just for the sake that it doesn't go, extinct. Like we have had multiple extinctions on this planet before. Also, we've had the dinosaur period and other times. In fact, the greatest threat we face currently in this era is not like nuclear wars or anything. It is a threat from an asteroid or something, like a rock flying into Earth and just taking us all out. So it's kind of also like an insurance for consciousness, don't you think?
Exactly. Right. That's the exact point I was, that came stuck into my idea. Right.
Exactly. So the end goal is really to make humans multiplanetary. And now to achieve that goal, there is a lot that needs to be done in terms of the technology, in terms of, getting people ready, the pioneers who will, do the mission. And this is a real thing. It's like, saying humans are going to go on the moon. Nobody really believes it at first, right? Nobody really says, you don't get to Mars or anything. People do say it, but eventually when it becomes a thing, then people really, start believing this thing. But engineers don't do it that way, right? Engineers really have to...
Sorry to interrupt. I would like to ask you, what do you think, how far we have achieved? What is the, if it's from 1 to 10, where are we right now? And I would ask viewers to, write in the comment section from 1 to 10 in this mission, where are we right now?
I think
what do you think?
Exactly.
Now coming to you, Akid. So what do you think, where are we right now?
Where are we right now? So if I break this, let's say if I break this into 10 parts, as you say, from 1 to 10.
Yeah.
So initial steps would be to obviously, building the technology, for example, reusable rockets, because you want to send people payload back and forth, correct? You want to go back to Mars, come back, go back to Mars. It takes usually around 6 months to get there. But there is also, Elon Musk has also said,
there is also, the cost. It's $73 million per trip.
Per trip.
That comes around 450 crore per trip.
Even with reusable rockets, you mean?
Exactly, with reusable rockets.
So that's like relatively cheaper than building it like from billions of dollars, right? It's like relatively
Exactly.
cheap. Exactly. That's what I'm saying. So if people are like, already scared about the cost, it's relatively much cheaper to build the rocket completely from scratch and kind of, get it out there. But the thing is, I was saying, you asked me where are we like in this thing. So if you break it into 10 parts, the technology that is needed, and you need to plan the mission. So initially, when you get to Mars, let's say you get to Mars, you send a human to Mars or a group of astronauts, group of team that goes there. They initially will have to live in these, domes, and they won't have really good supplies unless they start colonizing it little by little, building buildings, making the Mars atmosphere habitable, because Mars by itself is not habitable, yet. So there are a couple of challenges. If I break it down, we have, let's say, 3 stages. First of all, to get to Mars, that is one stage. Live on Mars, make its sort of atmosphere, the environment habitable. And third stage would be obviously to continue sustainably living there without having to require resources from the Earth. So that would be kind of the 3 stages. And I would say we have come pretty close to building reusable rockets, and kind of we might be in the stages of just sending people now in a few years, maybe 25, 30 would be where we get started with that.
So adding to the technological innovations and the hurdles, there are 4, I would say there are mainly 3 points, that we need to consider, and that fronts need to be, broken in order to achieve the goal. First is the intravenous fluids. I would describe it in the coming time. Second is, breathable gases. Because as we know, it's very
we need to breathe oxygen, right?
Exactly, that's very the surface is inhosted, right? So what about now? Let me just break it for the viewers. What is intravenous fluid? The fluid, the medical supplies that will be there. That has to be in a particular form, because we cannot directly take water, right? We cannot drink a glass of water on the surface of Mars, right? Because there is no gravity in such.
That is true.
We have to.
But you can drink it inside the space shuttle. Sorry again, but inside the space shuttle.
But we have to create
outside.
a system.
Yeah, exactly. The sustainable thing. Yeah.
So I am saying for the initial, steps,
phases. Yeah, exactly.
Exactly during the initial phases. So we have to, whatever has to be fed to the human system, for a human, it has to directly go through his or her bloodstream. So we have to create these kind of fluid system, where we can inject or we can use. So a prototype of this was tested in 2010 and at International Space Station, and work is also currently being going on. Next is, as I talked about, breathing gases, right? So as you know, we breathe purely oxygen. Viewers can ask what they are breathing right now. But there is a possibility of nitrogen that's being also included in it while we're breathing, right? So there should be an idea for keeping carbon dioxide out of breathing air, right? In Mars. So there is a concept of reusable, I would say, scrubbers, where we reuse the carbon dioxide. Here, plants are doing the job.
Correct.
So in order to replica the same, I have to take a plant with me.
Correct.
Still, I will not be able to fulfill the researches. So these are some things that we need to consider, and we need to prepare ourselves, and do some good. The direction of this should be in this direction, and that's how we'll achieve this feat.
In fact, one thing I would like to add, there is this game on Steam called Occupy Mars. Like, you see how real the thing is becoming.
Oh, I was not aware.
Yes, it is. There is a game on Steam called Occupy Mars. In fact, you do these. You talked about carbon dioxide scrubber, right? There's one more thing called plant incubator.
Right.
So what you do is there, you cannot grow seeds also. Like, you cannot grow plants. So what you do is you put the seed in the incubator. It grows into the sapling or whatever, just the initial stages of the plant, and then you move it to this another sort of tray or something where it then grows inside the sort of the pressurized container. Yes, not the incubator, but the thing, the pressurized thing, the chamber or something. It has to be pressurized, otherwise, obviously, it will not grow.
The ATM has to be maintained.
Exactly, right? the ATM, the pressure has to be maintained. Correct. So this is what I was saying. So there are lots of challenges, into getting. It's not just you can put a person there. So engineering teams who are behind it have to think about a lot of things, like right from the launch all the way up to sending people there, knowing how they will survive the first days, and it also gets really cold on Mars, like negative 50 degrees, like even colder than that. So you have to really think about a lot of challenges. The first is obviously reusable rockets, as you said. The oxygen is a problem, crop formation is a problem. So there are lots of challenges.
Yeah,
But
what about the artificial gravity?
Yeah, on the planet, I don't think we'll need the artificial gravity, right?
No,
Or
I
will
would
we?
like to quote
you have something?
Elon Musk here.
Mhm.
He said, "Let's bombard the surface of Mars with nuclear
Yes,
weapons."
to heat it up. I'm not sure what that has to do with the gravity, but yeah, the heat it up, definitely.
You recently said that you wanted to nuke Mars.
Yeah, so nuking Mars, I sort of was a little flippant about that. I think it's a really decent idea. Thank you. So yeah, what I was really getting at, but it's hard to, convey that in like 30 seconds, on the Late Show with Stephen Colbert, was that the sun is a nuclear explosion, a fusion explosion. That's what the sun is. It's an ongoing fusion explosion. So if you wanted to add energy to Mars, like warm up Mars, really the source of almost all energy in the universe is fusion.
So what is your suggestion on that?
I mean, I'm not really qualified to talk about that, but yeah, I mean, there is a way to, like, obviously you need Mars to be like, it needs to be at a sort of it needs to be at a temperature where finally you could maybe take your spacesuit out and and the atmosphere, the pressure, atmospheric pressure is high enough that make it rain on Mars, make its atmosphere thicker. Finally, you have to be able to take your spacesuit out, because initially you cannot take the spacesuit out. Your blood will start boiling the moment you remove your spacesuit, your blood will boil. Because of the low pressure, So obviously, I mean, I am not sure if that's a way to do it, nuking Mars.
Let's come back to Falcon 9.
Let's come back. Yeah, exactly.
The breakthrough in a rocket industry, right?
Mm-hmm.
So tell users more about the technologies that was revolving around this rocket system.
Yeah, that's primarily the greatest challenge is to land the rocket back. That's the sort of I would say the main goal. Of this thing. There's a lot that goes into it. There are really advanced flight computers that have to be there. There is something called thrust vectoring that goes into it. So a lot of different things. So the main challenge is that once a rocket this booster sort of launches, just a physics sort of perspective on it, it's going really fast. So it's going tremendously fast. It's moving more than 2 times, 3 times the speed of sound, and you cannot really stop it. Now, here's the thing. This is actually super interesting for the viewers also and for everybody. Some of them might already know it. When it sort of is going really fast like that, like at 2 Mach or 3 Mach, that is 2 times or 3 times faster than the speed of sound, you cannot really stop it. You cannot really invest energy into bringing it back to zero and then landing at the same spot. That is not really possible. So that's not
possible.
Yeah, that's not how they do it correctly. So the way they do it is they send a rocket up in the space. It sort of launches the payload at the escape velocity into the orbit or wherever it's going. And the booster sort of continues its trajectory. It just continues traveling in the direction that it's traveling. And the thrusters on the rocket, the side thrusters, sort of use thrust vectoring to kind of tilt the rocket so that it's kind of going like, I'm not sure if the people on the audio will be able to pick it up, but it just keeps going. It keeps its trajectory. The thrusters sort of turn it. And then it's supposed to land on, like, if you throw a ball, let's say, in the air, it has this trajectory that it sort of kind of follows.
That parabolic trajectory.
The parabolic trajectory, exactly. It keeps that trajectory. But the only thing is SpaceX, sorry, I think I hit the mic. So the SpaceX sort of tilts the rocket and sort of it lands it back on the drone ship or wherever it's supposed to land. And it's carefully done. You cannot really invest too much energy because you're not left with a lot of fuel. So when it sort of starts hitting the ground in the thicker atmosphere, they then just suddenly sort of, start the boosters and invest all of the energy to slow it down and sort of land it softly on the ground. That's how it's sort of, in the sort of big picture of how it's done. The challenge being, of course, it's traveling really fast and it has to be stopped and brought to the ground at the time.
I had a question. Is using this technology about the payload and the trajectory, is there any effect on the the amount of payload?
You mean in terms of what? Like in terms of like
the amount of payload it can carry and a normal rocket?
Of course. Falcon Heavy is one of the. I mean, few of the rockets that actually carries a lot more payload than a lot of other traditional rockets, because obviously it is powered by a lot of engines. It produces a lot of thrust. I'm not sure exactly how much thrust it produces, but it is one of the sort of the most thrust producing rockets. And second thing, the thrust doesn't even come from one engine. So there are actually multiple engines on Falcon 9. Not sure how many there are, but multiple engines. So even if you lose an engine, let's say a single engine, and if you have 12 engines, so you actually lose only 1/12 of the total thrust. So that actually is a nice sort of clever strategy, in the long term, don't you think?
Right, exactly. So considering now the let's now start with the timeline. So I would like you to share with the viewers what will be the timeline.
Timeline.
Starting with a common person. So I am considering the scenario when Earth will be kind of hostile.
Hostile, yeah, exactly. Maybe we will. Maybe our children can go there. I'm not sure if I can really go, but yeah, let's hope for the best. I hope the ticket becomes so like less costly or inexpensive that people are able to in fact travel. But yeah, the timeline. Elon Musk has said like there is like I don't know, maybe 2025 they'll be able, 2024, 2025 they'll be able to do the first Mars mission, and it's actually really hard to land on Mars because the time window is really small. So I think. You only get like a really narrow time window in which we can reach Mars in 6 months, because even though Mars is the closest planet, we are talking about the average distances between them. So I think when it's the closest, it takes 6 months to get there. And this is like because of the distance, the closest the Mars gets to Earth, it takes 6 months. But there is a way to get there in 3 months, but that's maybe a separate thing. But it takes 6 months for one journey to Mars. So it actually, you have to spend 6 months on the space shuttle, land on Mars, and then it takes 6 months to get back. So you can actually think it's not going to be possible for the people on Earth to send supplies like regularly. You don't expect like biscuits coming up daily.
Right. Made on Earth.
Made on Earth, exactly. So you don't expect that. Don't expect that. But timeline, I'm not 100% familiar with the exact timeline of events. I know that 2025 is going to be the first sort of mission to Mars, but other than that, yeah, you will start, for example, building a little space, a pressurized space where people would start. Obviously, the timeline is to first of all, use solar panels there, install solar panels. There's a lot happening. Again, this game that I was talking about, Occupy Mars, actually describes a lot of these things. So, for example, installation of solar panels, installation of hydration sort of plants where you can dig water out on Mars, because it's like frozen water. It's not really, it's ice basically. It's not water, like liquid water. So lots of things have to be done basically too. And there is also like installation of power packs, battery packs, and they have to batteries on Mars have to invest a lot of their power to stay warm. So there's a lot of challenges that there are going to be. I'm not sure when a common person will be able to travel. It's always going to be some astronauts, and then more astronauts, like that. The
more of a
pioneers,
technical people, right?
Yeah, I'm not sure exactly when we'll be able to, but yeah, maybe you have something to add to that.
So now let's now share with the viewers the life on Mars, or the exobiology of Mars, right?
Mm-hmm.
So why Mars? First of all, it's close.
Yes, please go ahead.
Second, and due to the planet's proximity and similarities to Earth, right?
Mm-hmm. Correct.
Till today, we'll like to share with the viewers, there is no fundamental proof of past or present life.
Correct.
That has been found on Mars, right? We have to be clear about it. All those scientific searches for evidence, it has been began since 19th century. But here's some findings of frozen water, I would like to say. So especially what is the composition, we're not sure about that. The rover that has been sent there is currently that's working on it. So the habitability of Mars, I'm focusing on the habitability because once we are there, what then? Are we going to survive there? Right? Because we have already taken a step to reach there, right? I think you said the timeline 2025, and based on the SpaceX work and the growth they are showing, I think they will be able to achieve this feat.
Let's hope for the best. Yes.
So habitability factors, what I consider are, there is water, chemical environment, energy for metabolism, right? How are we going to get the energy, and what are the physical conditions there? So for the viewers, I would like to add, there is a, as I said, there is a, water availability is there. For the chemical environment, there is a toxic abundance of, heavy metals like zinc, nickel, cobalt, chromium, which are very bad for your blood, right? And I would like to mention the metabolism, the energy required, right? So mainly that will be solar, right?
Correct.
Solar and maybe geochemical in a way, if we are able to develop some technology there. And the physical conditions, as I said, temperature is moderate as compared to the, it's in similar proximity with Earth. Although there is some fluctuations in temperature, strong fluctuations, which our body cannot handle as of now. Maybe we get, adapted over time. There is slightly lower pressure, atmospheric pressure than Earth. Okay. And another thing is there is very high concentrations of CO2, right? Unless you are a plant lover, it's not going to be an easy job for you there, right?
That's nice.
So based on, and there is some, UV induced oxidants are also present there in heavy quantity. So before going there, do use a sunscreen.
Okay, nice. Interesting point. Yeah.
Yeah.
So temperature fluctuates a lot. So for example, on an average, if you see on the Earth, the temperature does not fluctuate so much. If there is 50 degree in the day, there is, let's say 0 degree. It can go up to 50 degree. But on Mars, it gets really hot and really cold.
Right,
exactly.
right.
It gets like drastically cold. So you cannot really, metals will get cold. Your stuff will start freezing. So there's a lot you cannot really sustain without investing energy into heating, right? That's something that I wanna add. So where should we go from here?
Okay, so now I'm interested in what is right now on Mars built by humans.
Correct. Let's discuss that a little bit because 1 second, I'm gonna just cut you off here because it's not like we have not landed on Mars. Countries, I think 5 countries have sent and landed on Mars successfully. It's a hard job. I mean, definitely landing on Mars is a heck of a task, but it's not like we have not landed there. We don't already know a lot about the planet. In fact, people who don't know, we already have rovers on Mars. Curiosity rover is there. There are other rovers already present there. Some stuff, Perseverance, right. Exactly, Perseverance, and there's also something orbiting also Mars. So we know a lot about the planet, not as much as if we were really there doing the experiments ourselves. But yeah, we have landed on the Mars. We have
let's now go
sent technology
deep.
to Mars. Correct.
Right. Let's now go deep in this technology. What is the technology behind it? What are the drawbacks? What are the mountains we have to conquer yet?
Correct.
Right.
Please.
So Akhil, I would like to ask you, what's the prime technology behind these rovers in terms of I am
what are they sort of aiming to
traveling
do? Right?
traveling a lane here. I'm driving on a road and I'm driving on Mars.
There is AI involved, of course. There is AI involved.
Okay.
Is it going there or?
Exactly.
They are self-driving. They are self-driving. There is FSD, full self-driving, basically. So they do drive themselves. They do. There's no input basically from. So don't expect like a person on a keyboard sending input left, right, because I'll tell you why that is not possible. I'm not familiar with the core technology and what sort of AI, and you're the guy for the AI. But the thing is, it's not possible because light takes time to travel there. If you send a signal, let's say, it will take a lot of time for the signal to get there, and by the time you turn right, the rover might have fallen off the cliff, right? So they are full self-driving. There's AI involved. It drives itself. It digs holes itself. So a lot of self-driving. Yeah, a rover, if it's not like trained on, and it's not trained to kind of be a machine that is to be operated on the Mars, of course, it's going to face a lot of issues in terms of temperature. Obviously, there is like sun, there's like solar flares all the time. So it has to be built. Obviously, the rovers that go there are already built and equipped with a lot of this technology that they can survive those temperature sort of drops and solar flares and other things also. So
coming back to SpaceX, are they building any specialized rovers? If and what are the new technological interventions? So we need to dive back into SpaceX history. What they have developed so far, what they are developing, and what are their future goals.
So you mean is SpaceX building maybe some kind of a rover that we don't yet know about?
Exactly,
yes?
exactly.
Why not?
Exactly.
They could be
because
building.
they are innovative. This is one of the innovative company listed by Forbes, right?
Exactly. There is also one company that I want to mention about this. The robot Boston Dynamics. Yes, what you heard
exactly.
about Boston Dynamics.
Yeah.
So lots of companies are actually working towards building more advanced rovers. I mean, right now the challenges that rovers kind of face are kind of already taken care by the companies. Let's say the temperature drop, solar flares. There's a lot of things. There is also tornadoes that come on Mars frequently. So lots of challenges have been taken care of. But in the future, we might need more advanced rovers to do more important research on Mars, and that can help. They can become sort of companions to these astronauts. And so more advanced robots need to be built. Maybe Boston Dynamics can come in, and they might already be working on it. So yeah, lots of companies will I think come forward and help build this goal.
Right. So about the SpaceX and its reusable launch system, right? So for the users, I would like throw some light on how they started and where they are right now. So the program was started in 2011, which was founded by Elon Musk. So it achieved its first successful landing and recovery of first stage in 2015. That was a remarkable feat for the humanity. And the first reflight of the landed first stage was occurred in 2017. Right.
Yes, a lot of people might have seen that video actually.
Exactly.
2 boosters
That's
is coming
how.
now. Yeah,
right.
exactly.
That's how it started, and till now we are only
making progress. Making progress.
Exactly.
So
right. Yeah, you would like to add here?
Yeah, I want to add basically just for the viewers, just to summarize it. I don't want to throw them off, track. So basically, this whole mission that we are talking about, this making, humans multiplanetary, basically, it all began with Falcon. And the reason why we bought Falcon 9 in the beginning of the episode is because of that. This booster pioneered it all. Today, we have this SN series rockets for the Starship. Basically, we're not going in Mars in Falcon 9. That's a booster. There is another sort of ship. The Starship that is called, that is going to take you to Mars. But under the hood, Falcon Heavy is going to sort of power that. And that recently they also conducted a flight test which kind of combined the Falcon Heavy and Star. Even though I'm not sure if it's Falcon Heavy with some kind of other rocket, but I think 100%, probably 99% sure it's Falcon Heavy. And the Starship that was recently combined together and tested. Even though there was some kind of failure, but that happens. Elon Musk sort of believes in sort of reiterating again and again, and that's how he sort of makes progress, right? Making prototypes, just blow them up and then make progress like that. So yeah, lots of things are happening.
I would like to add the technical feasibility. Prior to this usability program success in 2015, as I mentioned, the return of the orbit launch system booster rocket, as you are mentioning, had never been accomplished. Right?
Never been. Yes, it's a very hard problem.
This was the first
very hard problem
in the course of humanity, and many questioned its both technical and economic feasibility. Right. So, and even after its success, the rapid reuse of rocket has not been attempted. The rapid reuse,
quickly refueling like a flight.
Exactly. Quickly. Developing a reusable rocket is extremely challenging. I would like to add for the users. So, because due to the small percentage of rocket mass, that it can make it to orbit, right? So typically, I would like to add a rocket's payload is about 3% of the mass of the rocket. The payload should be, it's
mainly
around
fuel. Yes, mainly fuel. The oxidizer.
Mainly fuel.
Yes,
mainly fuel.
Yes.
So that is, what Elon Musk said in the beginning of this program, that he believed that the return, vertical landing, and the recovery was possible because the SpaceX manufacturing results in the efficiency exceeding beyond this 3% margin. They are, pushing the limits.
And then here I would like to add something about the pushing the limits that you mentioned, and I'll talk for maybe 2 minutes. To make something like this possible, there is innovation required across many disciplines. First, you need a rocket engine that is really efficient. You can't really use solid rocket fuel. One that is, you can't really control how it burns, basically a solid rocket fuel. The engine was built and it was the first it was probably the most efficient engine that, people had seen back then, because it doesn't use solid fuel, it uses liquid fuel. It uses liquid oxidizer and liquid fuel that sort of combines in the chamber and sort of burns, and it's very difficult to even start that rocket. That's a topic for another time, but it's incredibly difficult. It's like a bomb. You have to start a bomb but control the flow of that bomb. So one thing, you have to make it really efficient. In fact, Raptor, the new Raptor 2 is one of the most efficient engines that there is, like 99.999% efficient. Like even with, as Elon likes to say, with the divine intervention, it can only become 0.1% better.
Right.
If God intervene, it can only become 0.1, because 100% is the efficiency that you get. You need to push the limits of physics, basically. And if it's allowed, you do it. That's one thing. So in terms of like the flight computers, things have to go really, really, well for something like this to be possible, because starting the rocket engine, cooling the engine chill, everything, getting the engine to the temperature where it is operatable is incredibly difficult. So as you rightly pointed out, you have to push the bounds.
Right.
So this is how
that's necessary, and that's how SpaceX have achieved this feat. Right. That's how we're discussing at 80 Talks podcast the future and that is
Humanity, yes, exactly. That is to
exactly,
come.
that's we have to go to Mars.
Correct. Correct.
Before 10 years, if you would have said the same thing to me, I would have laughed, a very, very good laugh, and I would have considered you crazy.
Correct.
Because the concept was not there, because the technology was not there.
Technology was not there. Exactly.
And they made it, they faced a lot of criticism while, developing this. He faced a lot of criticism, especially because when he announced it, people were also, the NASA,
Skeptic, yes.
they were very skeptical about it. They were doing this like the old ways, sending a rocket, getting funding and building another rocket and sending it again.
Correct.
It was
the government base again. Yeah, you know how government offices are. Nothing can tell you.
There were politics, and there were hierarchy and everything. He built the stereotype. He broke it. First of all, it was the first private company, and that is worth mentioning. And it has achieved, and now it's collaborating with NASA and other European space agencies, right?
True.
So that's where we have to take heed, and that's how we can contribute. We have to understand the mechanism, we have to understand the timeline, and we have to be, most importantly, prepared.
I think there is a time where they even started to reserve I don't know, seats or something, but you might have
exactly
heard.
Exactly the tickets and maybe a plot of land you will have to reserve for you on Mars, maybe.
Yes. Start buying land.
Exactly,
it's real. It's happening.
Right.
It might be cheap later. It might become really expensive, land. Land in,
the market can get very tough.
Exactly. So and it doesn't happen overnight, Tajamul. So as you said, people were skeptic for a reason, because one, it's a very hard problem. An incredibly hard problem. I mean, I cannot even, if there is a physicist watching me, they can tell me, even though we are engineers, we understand things also. But yeah, it's incredibly hard. Physics-wise, engineering-wise, it's an incredibly hard problem. And it doesn't happen overnight. People, when they first launched rockets, they blew up. Tens and tens of rockets blowing up, building new ones, blowing up, learning from that. And sort of this is how they believe in, iterating and having this rapid production.
There were, exactly. I would like to add here, sorry to interrupt. There was always news of another SpaceX rocket failing.
Blowing up, yes. In early days of NASA as well. People lock rockets blowing up before they...
About the Apollo, right?
Yes. Exactly.
So many unsuccessful attempts.
That's how we do it. Engineers, that's how we do it. We learn from something that we did. And if it doesn't work out, we just learn from it. We just collect data. Okay, this is what went wrong. Improve that. This is what went wrong. Improve that. So again, just to kind of put it out there, we don't go to Mars. This is not happening. Just for them, saying that this is a reality and you should start sort of thinking about it. Maybe, so that you can, be sort of future-proof in a way. Correct?
Right. So I was saying about be prepared. Don't just close your eyes. Don't be an ostrich and put your head in the sand. That's not going to work. Learn about it. Learn about the SpaceX program, reusability rockets, right? Maybe this podcast will help you, be a starting step for you. And if you want to learn more, you can use the ChatGPT program. And if you want to learn how ChatGPT works, what are the interfaces and everything, we have already made a video on it. Here's the link. You can click on it and, explore. So, okay, let's now summarize what we have learned and what we have discussed so far in this podcast.
Yeah, I hope I was, we were able to, yes, of course. So I hope, through this podcast, I was able to give insight to people who don't know about this and sort of provide an update on where this mission is going. So yeah, to kind of summarize it all, we will be going to Mars. And we'll be having, there's obviously the stages that we discussed, the technology that is being developed, getting there, living there, surviving there sustainably, that kind of scenario. And initially, obviously, the people who have the fortune to make it there will go there, primarily the astronauts and all of that, as we discussed. And the technology is actively growing in something also you can invest your money, time, energy to learn about it so that you can become sort of, as I said, future-proof about these concepts. So Tajamul, with that said, let us end this episode of AT Talks, episode 2.
See you soon, guys. Thank you.
Take care. Bye-bye.